All right, good morning. It's 8 o'clock, so we'll go ahead and get started. Like I put in the emails that I sent out, we'll cover today is some of the material from weeks 1 and 2, and also talk about your assignment that is due coming up on Tuesday, and then we'll have a question and answer session. So you can ask really anything you want to ask about Java or about the class itself. All right. And at any point, you can go ahead and interrupt me and either ask a question or put something in the chat box or anything like that. And, I'll respond back to you. You don't have to wait until the end if you want to ask a question about something that I'm doing right then. All right, so let's get started. So first thing I want to talk about is some of the material from week 1, actually. And really, it's about static versus instance. What is the difference between a, say, static variable or a static method versus an instance method or an instance variable? So as we go along, I'm going to kind of build on an example that'll lead up to something like the assignment. So let's imagine, so going back to static and instance, let's imagine we have a class called shoe. And we'll use this class to model a pair of shoes. So I have a class called shoe, right? We'll have variables inside there and we'll have methods, right? And so one of the methods that you always need to have a constructor, right? Constructor called shoe. Well, let's think about what variables a shoe might have. Well, there might be an ID for the shoe. Maybe it's like the stock number, or maybe it's the little barcode, whatever the case is. Let's just say each individual pair of shoes is going to have an ID. All right. What else does a shoe have? It may have a string that's the brand, right? Something a shoe might have. And then let's see, one more thing a shoe might have. It also might have the size. So let's just make that an integer, the size. We'll ignore half sizes. We'll just say the sizes, a size 8, size 9, size 10, and so on and so forth, right? So to make a shoe, to construct a shoe, we need to tell it what these things are. What is this shoe ID? What is its brand? What is its size? And we can do that through the constructor. And when we make a shoe, you'll see what I'm talking about. So we'll give it an ID, we'll give it the brand, and we'll give it the size. And then we need to save that to the instance variables. And the instance variables are these variables right here, the ID, the brand, and size. They're different in that they don't have the static keyword here. So what is static versus what is instance? A static variable means it belongs to the class. It doesn't belong to any specific instance of the class. It belongs to the entire class. Meaning, let's say if I had static here for the size, that means even if I created 100 shoes, they would all share this exact same size variable. So if I made shoe 1 and I set the size to be 10, whenever I make shoe 2, its size is also going to be 10. You can't have different values for the variables if it's static. Static just means it belongs to the entire class and not one specific instance. Now, when we leave off the static keyword, that means it's an instance variable. That means for each individual shoe that we create, it will have its own independent size, its own independent brand, and its own independent ID. And we'll explore that here in a minute. But for now, in the constructor, let's set the instance variables to the parameters I passed in. There we go. And let's override the toString method, so that if we want to print out a shoe, it'll print out this information for us. It'll tell us the ID, the brand, and the size. So if we want to, whenever we want to print a shoe, it's going to print shoe, let's see, ID. Let's make this real quick. It'll print out the word shoe. It'll print out the ID. It'll tell us the brand, and we'll print out the size, just so that when we print out a shoe, it'll actually tell us, the ID of the brand and the size. Oops. Turn this. Okay. So this is a basic shoe class. It has 3 instance variables. I have this constructor. Hold on 1 second. Give me 1 second. I'll get started again. I just have an email question about the meeting. All right. So I was just having problems accessing the class. All right. So let's get back to it. So as I said, this is a shoe class. It has these instance variables, the constructor, and a toString. And I'm going to demonstrate here shortly the difference between a static variable and an instance variable. All right. But in here, we all have instance variables. All right. So in our main, let's create a couple shoes. Make shoe. We have shoe 1, be a new shoe. We want it. We got to give an ID. So the ID is 1, 2, 3. The brand is Nike, and the size is 10. Okay, that's one shoe. Let's make another shoe. Shoe 2, be a new shoe. The ID is 2, 3, 4. Whatever we want to call it. The brand is Asics. I don't even know if that's how you spell it. The size is 12. Okay, and then let's just print out each of these shoes. Print ln, I think it is, if I spell it right. Here we go. We'll print out shoe 1, and we'll print out shoe 2. Okay. So let's run this. Oh, I need to set up my run method. And I'm using IntelliJ IDE for my IDE. You can really use whatever IDE you want, or you can just use Notepad and compile from the command line. It all works the same. All right, there we go. So let's run this. Just takes a second the first time. Okay, any second now, it'll finish compiling. I'm actually running this on a really slow computer, unfortunately. I'll use my faster system the next time we do this. There you go, Bill Sessions. There we go. So you see for the output, we constructed this shoe, we constructed shoe 2, and then we printed out both. And there's shoe 1, and there is shoe 2. Right? Of course, that's the ID, the brand, and the size, and so on and so forth. So as you can see, the ID, the brand, and the size, they're different from each other in each of the shoes, right? The variables are independent from each other. That's because they're instance variables. Now, if we had a static variable in here, static let's call it, actually a good use case is count. Let's say each time that we make a new shoe, we're going to increment count. For the question I have in the chat, I'm not going to go back right now. This is being recorded though, and I'll have it posted online so you can watch from the beginning if you need to. All right, so now let's say we have this static variable called count. As I said, a static variable means it belongs to the entire class. It does not belong to any specific instance. Meaning in our main here, where we have shoe 1 and shoe 2, they will refer to the exact same count variable. If I change count in one of those, it changes it in the other. It belongs to the class and not any specific instance. So what we can do, we can actually use this to count how many shoes we create. Let's say each time we have a shoe, we're going to increment the count variable. And as you can see here, I access it with the shoe dot, the variable name. And that's because it may let you get away with it with this. It does work if you use this. But I mean, the IDE actually gives you a warning, access via instance reference, when it should be accessed via the class, because it is a class variable and not an instance variable. That's what static is. So let's imagine, so each time, whenever the constructors run, we increment count by 1, right? Let's add on here to our output. We'll print out what the count is so far. Was it shoe dot count? Okay. So now let's go back and look at this. So when we create our shoe 1, it'll go into the constructor. It'll assign these variables. And it'll also increment count by 1. So right now, count is 1. Because count starts out to be 0. This is the first shoe, so count is now 1. Now we come in here and we make shoe 2. So it goes to the shoe 2 constructor. Count is already 1. But now we're going to increment it by 1 again, so count is 2. And that's because this count variable is shared between all of the shoes that we create. It is in common to them all. And that's because we use the static keyword. So let's make 3 shoes actually. Make 3 shoes. Change the ID to something different. Change the brand to Puma. Size 11, something, right? Let's save it and run this. Now I compile it a lot faster. Oh, we need to print out shoe 3. Now we'll run it. Now you can see shoe 1 has all this information and it says the count is 3. And why is that? That's because we have made 3 shoes. So that count is shared between all 3 of them. We could actually make a loop if we wanted for int I equals 0, I less than, let's say 1,000. All right, plus plus. Let's make 1,000 shoes. And then we'll just print out a shoe each time we make it. So we're having a loop. We're going to loop 1,000 times. Each time we're going to create a shoe. And then at the end, and each time we'll print out that shoe each time through the loop. We'll run this. You can see we print out like 1,000 shoes, and each time the count gets 1 bigger. So here I made shoe number 995. We looped again and we made the next shoe 996, 997, 998, all the way up to 1,000. That's a good use case for using a static variable, is counting how many times you have made one of these classes. Like I said, the key thing to remember is this count belongs to the class as a whole and not to any specific individual shoe. So that's the difference between static and instance variables, where static belongs to the whole class and instance can be different for each individual shoe that we create. Okay, that's really all that week 1 was about. It's talking about static and instance. Okay. Well, to continue on with the rest of the material, I don't need the static anymore for those demonstration. So we'll remove the static back out of there. Okay, so let's talk about the week 2 stuff. Talk about encapsulation. Well, first of all, let me add one more variable on here. We'll call it the price. And how much does a shoe cost? Private float price. We'll add it here to our output. S plus equals price, and we'll print out the price. All right. And now in here, we need to compute the price, right? What is the price? So we have a couple of options. You know, here we could put, as part of the constructor, we could put, you know, what should the price be? And we could set it like that. That's one way to figure out the price, is just have the main function give it to us. So if this were the case, you know, with ID, brand, and size, we also need to give it the price. Let's say it's $49.99, right? Let's just make like 10 of these instead of 1,000. Let's say the price is $49.99. So if we run this, should work perfectly fine. You know, we'll make 10 shoes, and there's all the information: the ID, the brand, the size, and the price. All right. Let's take it out of the loop so that we can change up some of the variables. So there's shoe 1, shoe 2, shoe 3. Let's make our different shoes again. Let's change up the ID so they don't have the same ID. Change up the brands. Change up the sizes. And change up the prices. And then we'll print out each shoe. All right, let's run it just so that we can see it prints out what we expect. And there we go. There's the first shoe, the second shoe, and the third shoe, right? Okay, so that's one way we could do the price. But let's say we want to compute the price according to some mathematical equation, right? So instead of passing in the price as a parameter, let's say the price is equal to, let's say, like a base price of $39.99 plus the size times 10. Yeah, I don't know. Size times 2. Let's just say that's the equation. Is that a realistic price? I don't know. Let's just say we did some marketing research or whatever, our accounting department or something. We decided this is the way we want to compute the prices for shoes. Okay. So now let's see what happens. So now in main, we don't need to give it the price as a parameter anymore. All we need to give it is the ID, the brand, and the size, and it will compute the price for us, right? There we go. There are the prices. So the Nike is $59.99, the Asics and the Puma, and so on and so forth. And that's because, you know, we gave it these sizes. For example, the Nike has a size 10. And so we're saying the price is $39.99 plus 10 times 2. So that's 20 plus $39.99, and we get that as a price. And that works out right? That's a price. So how does this relate to encapsulation? So encapsulation, what it boils down to is I don't care about the internal workings of another class. I don't care about the internal workings of another class. I only care about what is visible from the outside. So what do I mean from that? So when we look at this, when we look at it from the perspective of main, out here outside of the shoe class, I can't see any of the internal variables. For the question in the chat, for the item ID, why not just have it as an object variable that increments each new item initialized? Sure, you could do that. And what it means by that is we could actually make the ID static. Instead of passing in the ID, that's actually a good use case for it. Instead of passing in the ID, actually, we do need a, oh man, here we go. So undo some of these changes. All right, so we'll keep that ID. Let's keep doing that counter we had earlier. And so now instead of passing in an ID, we can just have the ID be equal to what the count is, right? So we'll start off with, like we did in the static example, we'll increment count by 1. And so here we can just say the ID is equal to the count. That's a good way to do the ID. Let me show you this works real fast. Oops. So now we don't need to pass in an ID. An ID is made for us. Yeah, there we go. So if we do this, we run it, we see it's now generating these IDs for us. And the ID is going to be based on what this count value is, as we discussed earlier. Since it's a static variable and we increment it each time, it basically counting up for us how many shoes we've created. You could also do something like this. You can make it a random ID. Let's just show a bunch of different ways you can do things, I guess. New random dot next, I think it is, next int. That'll just generate a random integer for the ID. You just want to do that. Let's run it. Yeah. Now, as you see, we get random integers as IDs. So there's actually a bunch of different ways you can generate IDs and things like that. So yes, to your question, yes, you could absolutely do that. Okay, but for us, let's just stick with what we did here now. Count. That way the IDs stay pretty small. We can work with that. Okay, so going back to what I was talking about encapsulation. Encapsulation means you don't care about the internal workings of another class. You don't care what it does internal to itself. You only care what it gives back to you. Right. So from the perspective of main is outside of the shoe class. So main does not know anything that is private. It just doesn't. It cannot access what this price is. Meaning in main, I cannot do system.out.println. I can't do shoe1.in_price. I can't do that. It's an error. And that's because this price, as you see here, has private access. That means from outside of that class, I cannot access that price. Well, you may think, well, okay, well, let me just go in here and make it public. So now I can access that price. So let's imagine we're making a program. Let's delete these printouts. Let's imagine we're making a point of sales program where we're selling somebody a pair of shoes. We'll say somebody has some money, they have $100, right? Somebody has $100. And they want to buy shoe number 1, right? How much money, how much change do we need to give them, right? So let's say they give us $100. The change would be they're going to buy shoe 1. Excuse me. The change is going to be how much money they have minus the cost of a shoe, right? Shoe1.price, and then we'll system.out. Println. We're just going to print the change, right? We'll just do that right there. So they gave us $100. We're going to calculate the change by what they gave us minus the cost of a shoe. And then we're just going to print out what the change is. And this works. But here in a second, I'm going to show you why it's bad. And there you go. Their change is $40.01. And that's right. Right. But this breaks encapsulation. As I said, there is almost never a good reason to not use private for internal variables. If you're using public for an internal variable to a class, it's usually a really bad sign. You shouldn't do that. And here I'm about to show you why. So, this may seem simple from, a program that has 6 or 7 lines in it. Well, what happens when you have a program that has 10 million lines of code in it? Right? Let's say somewhere along the way, I just changed the price of shoe like this. Right? Somewhere along the way, I just did this. Because when a variable is public, not only can it be read, but it can also be written to. Here, we're changing the value of price inside of that shoe instance, right? So now when we run this, their change should be 1 cent, right? Oh, well, why there's extra numbers there is a long story, and I'll actually make a post about that, but I'm not going to go into it now. But for all intents and purposes, their change is 1 cent. Right? So what is the problem here? The problem is, we had a mathematical formula calculating what the price should be. And it was based on the size. But here, since I've left price public, that means anywhere else in the entire program, I can change what the cost is. And that breaks the encapsulation. That's not something we want to do. So let's change this back to private. As I said, there's almost no reason a class variable should be public. If you come across a good reason, let me know. But it's really hard to come up with a good reason why a class variable should be public. So always mark them private. So then, how do we calculate the change? Because we do need to know what the price is. We need shoe to tell us what the price is. So how do we get the price? So question in chat, can't you still change them with encapsulation via setter? It just takes an extra step. Yes, what he means by setter is, so instead of having it public, maybe I have public void set price, float new price. This dot price is equal to the new price. Absolutely, you could do that. But if we don't want to allow the price to be set externally, then we just don't include this method. Right? So this forces us to basically explicitly state that you can change the price externally. For our shoe example here, I don't want the price to be able to be changed outside of the shoe class. Because as I said, the price of a shoe is based on this formula and what the size of it is. So I don't want to let anybody else set the price of a shoe. And I can prevent them from setting the price of a shoe by just not having that setter method. Right? But let's say, let's take your example and go one step further. Let's say we do want them to set the price externally. And conversely, we'll need a getter method to get the price. So we have a method set price and it changes the price, and a method get price that gets the price. So we can use get price here, and now we can correctly compute the change, right? This will now tell us how much change there should be without using that variable as public. Let me run that, and then I'll get back to the setter after we show this. So when I run this, there you can see the change is $40.01, and that's right, because let's print out the shoe here again. Hour out. Shoe one. Just print out the shoe and then print out the change. So there's the shoe I'm buying. The price is $59.99, and there's the change that we owe, $40.01. Okay. So that works with this get price method. So the price variable is no longer public. The price variable is still private, as it should be. But we have a way to get the price so that we can do a calculation with it. That's encapsulation, meaning we don't make the internal variables public. So what about the setter method, the set price method? Sure, right now I could do, let's see, shoe one dot set price, and I could still change it. Let's just change it to $1. Right? Oops, didn't mean to run it yet. After I change it, I wanted to print it back out. So here we go. We print out the original shoe. I set the price to $1. We print it out again. As you see, the price is $1, and there's their change, 99. Okay, so maybe you want to allow that functionality to set the price. I didn't. I did not want them to be able to externally change the price. So if we don't even include that method, I just comment it out, meaning that method is not available. They can't change the price. But let's say we did want to allow them to change the price. So how is this any better than just having a public variable? That may be the question, because I'm still able to get the price and set the price to anything I want. Why not just make the variable public, you may ask? Okay, well, let's imagine this. Let's make it public again. Let's make the price public. We'll take away the set price and the get price. So now we don't have that set price. We don't have the get price anymore, but the price is public again. So we can just use it like that. I'll get to your question in chat in a minute. So let's say I did this. Shoe one dot price is negative $100. You go pick up a pair of shoes and they give you $100, right? So there's no control over what I can set the price to. Let's run this. There's the shoe. It costs $59.99. I changed the price to minus $100. The shoe is now minus $100. They give me $100, and I give them in change $200. So they walked out of the store with a pair of shoes and an extra $100, right? That's bad, right? So we need some control here over what the price is set to. So encapsulation, let's change it back to private. Let's bring back our set price and bring back our get price. So in set price, we can do some sanity checks. What I mean by that, we could say if the new price is less than 0, system.out.print, you are out of your mind, right? You're not giving away a free pair of shoes. And then we'll just return them without changing the price. Right? So now we can do a sanity check. If we're trying to make the shoes actually less than or equal to 0, if you're trying to make the shoes free or cost less than $0, then it's going to print you are out of your mind, and it's not going to let you change the price. All right. I do see your questions in chat, and I'll get to them after I run through this example here. All right. So now let's go back here. Price is no longer public. We use the getter, the get price, and we use the set price. So We'll make the shoe. Let's take away these other ones. Make the shoe. We'll print out the shoe. We'll set the price to minus $100, minus $1,000. We'll at least try to set it to minus $1,000. We'll print out the shoe again. Then we'll set the price to $10, and then we'll print out the shoe again, and then we'll sell it to the person, right? So let's look at the printout, and then we'll walk through each line of code. So run this. There we go. We have a shoe, the original shoe we constructed, and it calculated as $59.99. We try to set the price to minus $1,000, and it tells us you are out of your mind. You can't. I'm not going to allow you to set the price to a negative number or even zero. You can't set it to zero. So then we'll print out the shoe again, and this shows we didn't change that price. It's still the original price because I did not allow you to set it to a negative number. Then we set it to $10, and that's acceptable. And we print out the shoe, it costs us $10. And then we calculate their change, which is 90. So that's the point of not making these public, because you don't want to be able to access them directly from outside of this class. You don't want the price to be manipulated without you doing some sanity checks and making sure it's okay. So let me look back at these questions and I'll answer them. So does Java have underscore and double underscore methods, or is it just the private keyword like how in Python? Nope. You have to explicitly use private. Let's see, the different modifiers you can have. You can have private, which means you can only access it within this class. You have public, which means it can be accessed anywhere. It can be accessed from main, it can be accessed in another library, whatever the case is, it can be accessed anywhere. And then you have what we call package private. Let's see if we had another variable int y. Right? That means this y can be accessed outside of shoe, but it has to be inside the same package. And the package is what we have labeled up here. Like this is package CMIS 242. Since main has the same package, it would be able to access that y. Main would be able to access the y because they're the same package. But if this package were something else, disregard the other errors that popped up. But if this package was something else, then it would not be able to access that y. With no modifier, it means it is package private. So there's not really a good reason to use that either. So like I said, you want to use private unless there is a really good reason to use public. And I can't think of a good example right now of why you should have a public variable. All right. The other question is, it's bad practice to utilize the variables from the class in main. And that's absolutely correct. And that's just what we were demonstrating is it is bad practice to use internal variables from main or really from anywhere else outside the class. It is absolutely bad practice to use those variables directly, which is why we make them private. So programmatically, it forces us to not use them somewhere else. Because I mean, I could have this as public, right? And here I'm still not accessing it for my main, right? But the thing is, I could access it for main. And you want to prevent that from being able to happen. So you make it private. So this keeps it keeps you from mistakenly using it in bad practice from somewhere else. Okay, so that's encapsulation. That is about private variables. So really, whenever you're doing your homeworks and assignments and stuff like that, and you're turning them in, if you have public here, or if you have it just blank and have it packaged private, you're probably going to lose a point or two because it's breaking encapsulation, and it's extremely bad practice to do so. So always make sure your internal class variables are marked as private. Okay. And that is really what the focus of this week's material was. And I say at the beginning of the video, excuse me, at the beginning of the Zoom, I covered the static versus instance. If you weren't here for the very beginning when I did the static versus instance from week 1, this is being recorded, and I'll have it posted up later today and get the link sent out so you can go back and rewatch it if you missed anything. All right. The next thing I'm going to hit on is your assignment that is due up on Tuesday. I said during any of this, if you have any questions, let me know. You can interrupt me as we go along, but I'll just go through kind of a little bit about your assignment and help you out with a little piece of it that you can then probably expand on to finish out the assignment. So for the assignment, let me bring it up on my screen. Where's it at? There we go. So it's about making basically a book inventory, right? You got to make a book inventory. You got to track some books. You got to add some books to a list. You got to remove a book. You got to find a book, and you got to display a book, right? And you got to provide like a little menu that lets you, excuse me, select from those various options. All right. So the part I'm going to help you out with is we're going to make a list of shoes, and I'm going to show you how to add a shoe to the list of shoes. All right. And so then you will need to expand upon that to do books instead of shoes. And then you'll also need to figure out, well, how do I do the remove? How do I do the find? And how do I do the display? Right. But that's what I'll leave up to you. But we'll do an example with shoes. Okay. So we've been doing our shoe class. We already have the shoe class built out, fortunately. All right. So let's go to our main. Let's delete out everything in here. So we need to have a list of shoes, right? There's actually there's 3 good ways to maintain this list of shoes. And actually, I'll go through all 3 of them, and you can decide what works best for you, okay? So one way to maintain a list of shoes is with just a normal standard Java array, right? So in main here, we will have an array of shoes, right? Shoe, we'll call it shoes equals, it's just a shoe. We'll have a new shoe array. And let's say we want to keep 10 shoes in there. So we have a shoe array that can have 10 shoes in it, right? And let's make some of the shoes. And we'll make some shoes, but we'll also keep track of how many we created. In the question, we have a question: using insertion sort should be the easiest way to keep the list right, since Java automatically shifts the list items, right? Well, does the homework say anything about sorting? It does not. If you want to do an insertions, I have problems saying the word. If you want to use insertion sort, feel free to go right ahead to. However, the homework does not require you to keep them sorted. It just wants you to have a list of books. The homework doesn't tell you to sort the list of books. It just says have a list of books. So if you want to use a sorting method on it, feel free to. I do caution against doing extra things that are not in the assignment. And I caution that because let's say if you want to do your insertion sort, if you mess up the sorting and your program crashes or it gives the wrong answer or something like that because of your sorting, then you're going to lose points because your program did not function correctly. So from my opinion, I would not include sorting because the assignment does not require you to include sorting. If you include sorting, it's something else that could go wrong that you could possibly lose points for. So I'm not saying you can't use a sort, but if you do, and if your sorting is wrong, you may lose a point. Okay. So getting back to this, so we're going to have an array of shoes, and then we want to keep track of how many shoes we have, and we'll just call it count. So starting out, we have an array of shoes, and we have 0 shoes so far, right? So let's make a pair of shoes. In your program, you need to get input from the user. You need to read in from the keyboard. You know, what's the book name? What's the book author? You know, all the things that it wants you to have. Actually, for the book, you need to have an ID, a title, and a price. So you could have the user input an ID, or you could have it generated automatically, kind of like I did for the shoe. For the title, you need to have the user type in at the keyboard what the title is. For the price, you can either have the user type in the price, or you can have it computed automatically, whatever you want to do. But either way, you know, as part of your program, you have to have a loop that's asking them, you know, type in the name, the title of the book, and so on and so forth. I'm not going to do that part of it. Like I said, I'm not going to cover every aspect of the assignment, but I'll cover keeping track of books and adding a new book, and then it'll be up to you to figure out the rest of it. Okay, so we have an array of shoes. Let's make a new shoe. So how do we do that? We have shoes at index count is equal to a new shoe. And what we got to give the brand and the size, right? So since we've made a new shoe, I want to increment my count variable. Okay. Let's make another shoe. Actually, this would be a lot better if we make a method for it. So let's make a method. Add shoe, and we'll give it a shoe we created. Shoes, and this will make sense in a second. Oops. Shoes. We'll see why I'm doing this in a second. As soon as I get it typed out, I will explain. All right, so here as part of the class, as part of a class variable, as I said with static, I'm making an array of shoes, and I'm saying that it can have 10 shoes in it, and then I have the count, right? So let's make a new shoe. We'll have it with add shoe, and we'll give it the new shoe to create. Oops. So add shoe like that. And so inside the shoes, here's how we would add it. Okay, let's see if there's one. All right. Actually, let's make one modification to shoes so that it more closely resembles what you got to do for your assignment. So instead of the ID being generated automatically, we're going to pass as a parameter to the ID. So this is what you got to do for your assignment. We don't need that count anymore. Okay, so just the change I made is we're now giving the ID as a parameter instead of generating it automatically, because that's what you got to do for your assignment, right? So here, shoe ID 123 Nike. So let's make, say, 3 shoes. 2, 3, 4. 3, 4, 5 is the IDs. Have a Nike. We'll have a Puma. We'll have a Converse. And let's just make different sizes. 12. Okay. Let's make another method to static void print all shoes. And how do we do that? Let's make a loop. Loop starts at 0. It'll go up until count, because count is counting how many shoes we have, right? So then we'll just print out the shoes at the index I. If any of this looks foreign or not familiar to you, these are just basic Java constructs, such as making methods and making loops and stuff like that. This is the 242 class. It's not the 102 class. So there is some expectation that you understand loops and things like that. If you don't, you can get with me offline and ask for assistance. But when I do things like loops, it's with the expectation you already understand what a loop is and how to make one. Okay. So we'll make those 3 shoes and then we'll print all shoes. So what are we doing here? We're calling the add shoe method with this new shoe. We're doing it 3 times. So each time we add a shoe, we're putting it into the array and then we're incrementing the count by 1. And then of course, printing all shoes just loops through the count number of shoes and prints them out. Let me run this and show you it works. There you go. We added the 3 shoes and now we're printing all the shoes. And those are the 3 shoes. So for the very, very extremely basic add, that's about all there is to it. There is a caveat though. Actually, there's 2 caveats. So let's change this from 10 down to 4, just a more manageable number. So we've added 3 shoes, right? Let's add a 4th shoe. 3, 4, 5, 4, 5, 6. What's another shoe brand? A6, size 13. Does this work? Let's run it. This works. Let's add a 5th shoe. 4, 5, 6, 5, 6, 7. Brand, I don't even know. New Balance. Yeah, there we go. New Balance. I like New Balance. Make it size 14. What happens now? Bum, 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 bum. We have an exception. We crashed our program. Why is that? Because we said the shoe array can only have 4 shoes in it, but we're trying to put 5 shoes in it. This is bad. It crashed my program. Luckily for Java, it'll give you an exception. It'll crash out. If you're using a language like C or C++ or some of the C variants, this is what we would call a Stack Overflow error, and it can lead to bugs that are hard to catch, but also this is how a lot of hacks and a lot of compromises of systems and vulnerabilities, a lot of them are caused by what we call stack overflows, meaning we're trying to use more memory than we actually have. So I said we could have 4 shoes, but I'm putting 5 shoes in it, right? That doesn't work. So one thing we could do here, one of the checks we could do, we say if we already have 4 shoes in it, if the count is already 4, we could just say, sorry, no more room for shoes. And then we put the else to actually add it, right? So we have an array for 4 shoes. We're trying to add 5 shoes. So here we're going to check, are there already 4 shoes? If there are already 4 shoes, we're just going to say, sorry, no more room for shoes. And then, but if it's not up to 4, then we'll go ahead and add it. So let's run this. You see, we get the sorry, no more room for shoes. That's because, and let's tell it what shoe we couldn't add. Plus shoe. That way it'll tell us what shoe it couldn't add. There we go. Sorry, no room for shoes for this shoe. It couldn't add the New Balance, that size, and that price, right? That's because we added 1, 2, 3, 4. We tried to add number 5, but we don't have room for number 5. So we said, sorry, no more room for shoes. And we did not add it. So that when we printed all the shoes, we don't get the New Balance shoe printed out because we didn't have room for it. Okay. So that's one of the caveats you have to take care of when you're using a raw array like that. I'll show you the other methods besides raw array in a second. But another part of the assignment I want to mention first is, first of all, I'm going to read verbatim what your add is supposed to do. So it prompts the user for book data and add to the inventory list. Here's the key. If the book already exists based on the ID value, the add request will fail and an error message will be printed to the console. So that's telling us if we try to add a book with the same ID as an existing book, it should fail and it should tell us it failed. So for our example, whenever we add a shoe, if the ID already exists, then it should fail. And it should tell us that it couldn't add it, right? So here we're checking if we have too many shoes. Now we need to check, does that ID already exist? So let's do this. Let's make another method. We can make this one private. We'll have it return a Boolean, and we'll say, does ID exist? And we'll give it the ID, right? So in this method, we're going to return true or false if the ID already exists in our list of shoes. For the question, so for the error, should we use system error.println message? That's fine. You can use system.error or system.out.print. Either way, from a normal terminal or console window, it both just gets printed out to the screen. So if you wanted to do industry standard, then yes, system.error.print. But if you put system.out.print, I have no issue with that. All right. So let's look at our method here for does the ID exist? So we need to look through our list of shoes and see this ID right here, does that ID already exist in the list of shoes? So let's make a loop through all the shoes. So we say, if this ID, let's get a handle to the shoe. This shoe, actually, yeah, shoes at count. If its ID is equal to this ID, then we're going to return true. That ID already exists in the list of books. If it gets to the end of if it goes through all of the loop and it does not find a match, then it'll get down here to return false, meaning it does not find a matching ID. So again, we're going to loop over all of the shoes. If this shoe.id is equal to the ID I'm looking for, if they are the same ID, then it's going to return true. The ID does exist. If it gets through all of the loop and it doesn't return true, then eventually it'll return false, and that means the ID does not exist. And of course, this is red right here. And why is this red? It goes back to encapsulation, right? In shoe, the ID variable is private. So what should we do? Should we mark this public? And if we do, the problem goes away, right? It fixes this immediate problem, but again, it breaks the encapsulation. You shouldn't have this. You shouldn't have the internal variables public. So we'll keep it private. And like we saw in the chat, we use a getter. We use public int get ID, return this .id, right? So we're able to read and get what the value is, but because I'm not using a setter, just like we have set price, I don't have a set ID because I don't want them to change the ID. Okay, so instead of that, we can use the get ID, and there we go. So now we have, does the ID already exist? Returns true or false. So here, when we're adding a shoe, well, we can first count if there are too many shoes, then we just want to print, sorry, no more room for shoes. We have another else if what I call it, does ID exist? Does ID exist? Oh, sorry, this does need to be public. The method needs to be public. Does ID exist? There. Am I doing wrong? No, I'm doing it right. And then the ID, this shoe dot. So why is that giving me a problem? Oh, it needs to be static. My mistake. And the reason why I'm making all these methods static, just like with a static variable, the variable belongs to the entire class and not a specific instance. When we have a static method, it means the method does not need a specific instance. It does not need an instance of it. It can just operate on the whole class. All right, so now let's go back here. So we're going to say if the count is equal to 4, meaning we're already, completely capped on our number of shoes, we'll print out, sorry, no more room for shoes. Now we're going to say, does the ID exist of the shoe we're trying to add? So we're getting this shoe's ID, and we're going to say, does that ID exist? If the ID already exists, sorry, this ID already exists. And then we can keep the else to add the shoe if it passes those checks. So let's go back here. So if we run it as is, shoe get ID. What did I do wrong? Shoes count. Oh, shoes count is null. Give me 1 second. I actually don't know what I did wrong here. Wow, this is embarrassing. Well, what we can do, let's debug it for a second. It's actually good stuff here. All right, shoes count 0. Step into it. Step into it. There we go. Count is 0. Turn false. That's fine. Adds it. Add the second shoe. Count is, why is count 1? Oh. Sorry about this. Why is count 1? Count should not be 1. I'll change this. This should not matter. That's why I don't like using raw arrays anyway, right? I is equal to 0, I less than count. Wow, it should not be like this. I may just have to abandon this and show you the other methods. Oh, I know why now. So when I did the add, where's the add shoe? There we go. Put the breakpoint there. Sorry you have to watch me do this. This is such a simple example. It should be fine. Count 0. Count still 0. Count is 1. Oh, that's what I'm doing wrong. This should be I. Whew. So I was losing my mind. All right. Now let's run it without it crashing. Sometimes even experienced programmers make little mistakes. So there we go. All right. So we try to add these 5 shoes. Right now, they all have different IDs, right? But on the 5th one, we get, sorry, no room for shoes, and then it adds the rest of the shoes. Let's say, let's not worry about the 5th one anymore. Let's just say we have 2 shoes we want to add. The first one has ID 1, 2, 3. The second one has ID 1, 2, 3, right? So what's going to happen if we try to add 2 shoes with the same ID? We run it. And it's going to say, sorry, this ID already exists. And let's print out what the shoe is too, so we know which shoe it's saying this about. And there we go. So we add this shoe. Now we're trying to add the Puma with the same ID, but it's going to say, sorry, this ID already exists. This Puma ID already exists. So then when we print all the shoes, it's still only giving us the first shoe, because when we tried to add a shoe with the same ID, it failed, and it told us it failed. And that's what you have to do with your add for your books. You also have to do something similar whenever you do the remove functionality. You need to check, does that ID exist? If it doesn't exist, then you give an error. When you do the find portion of the assignment, if you try to find a book with a specific ID, if that ID does not exist, then you have to fail and you give a message, right? So kind of the same thing that I've done for the add here, you got to do similar things for the remove and the find. And really, this is about all you have to do for display, right? This is displaying all of my shoes. This is really how you can display all of your books. Okay. So this is a decent sized portion of what you have to do for your assignment. But this is just kind of looking at the add method. You have to do the remove, the find, and the display. Also, I'm not getting any user input here. I'm just manually calling these methods. You have to get user input. You need to ask the user, do you want to add a book? Do you want to remove a book? Do you want to find a book? So on and so forth. Probably have like some kind of menu. And then, if they select add book, you have to let the user type in the ID, the title, and the price. And then you need to add it. But this is the basic outline of how you do that. Okay, so the 2 other things I want to show you real fast, and then we'll open up for any kind of questions and answers you may have. And we got about 22 minutes left, so I'll try to get through this a lot more quickly. So instead of just a raw array like this, where we are limiting ourselves to 4 shoes, and if there's more shoes, it gives us problems, right? We have some things in Java. One of the things is called an array list. That should be right. No, let's just do it like this. Oh, shoes. If I can type right. There we go. We have what we call an array list, meaning it's an array, but Java will manage a lot of the internal stuff for us. In normal everyday programming for me, I use array list a lot. I use a lot of these other things that I'm going to show you a lot. It's probably been a very long time since I've used just a raw Java array, or really in any programming language. Okay, so let's go back. So we got a few errors that popped up, right? And that's because we can't just use shoes like a normal array anymore. We have to use it like an array list. So one thing we don't need this count anymore. We don't need count. This array list will internally manage that count for us. So let's go fix up these errors. So here we're checking if the count is 4, sorry, no room for shoes. With an array list, there really is not a limit to how many you can add. Well, practically speaking, well, technically speaking, there is a limit. You know, how much memory is installed in your computer? How much memory can Java consume? You know, whatever answer that is, there is an upper bound to the number of shoes that you can have in this array list. But practically speaking, especially for like what we're doing in this course, you can put as many shoes in there as you like. So we don't need to worry about having a maximum number of shoes. If we wanted to artificially limit it, meaning let's say the program says you can't have more than 4 shoes. So not a limit to the array list itself, but let's say the assignment said you can only have 4 shoes. And we can do shoes.size, and that'll tell us how many shoes are in there. Let me show you this works. Change up the ID so we don't get that error. 3, 4, 5, 4, 5, 6, 5, 6, 7. Okay, so here we want to add 5 shoes. Actually, we're gonna have to fix up the rest of the errors before we can run it. So I'll go back and explain that once we're able to run it. Okay, so we're checking for the size. We still need to check, does that ID exist? So then if it passes both of those things, we need to add it to the array list. So we can do that with shoes.add. And inside there, we put the shoe we want to add. And that's it. We don't need that. We don't need the counter. Remember, shoes is this array list, and we're just going to say, add this shoe to it. Okay. Now, when we print all shoes, shoes.size tells us how many shoes are in there. So we can have this loop that goes over how many shoes are in, or how many shoes are in that shoes array. And then here, instead of accessing it like with this index, we just do shoes.get and the I one. That's how we can go over all the shoes in the array list. And then here for does it exist, similar with up here how we did this loop, shoes.size. Shoes.size is how many shoes there are. Instead of shoes with the index I, it's just shoes.get I. So the shoes.get, that gets us one of those individual shoes. So this is a shoe. And then we're just doing the get ID on it. And this should work fine. So we run this. As you see here, we're still getting the sorry, no more room for shoes. And that's because we're doing this check here. Like I said, that's only an artificial limitation we're placing on ourselves. You know, if the assignment said only have 4 shoes, but the assignment doesn't say only have 4 books. So let's take out that size requirement, meaning we can have unlimited number of shoes, depending on how much memory you have in your computer, of course. So when we run this, now we're getting all 5 shoes. Let's make a loop. Int I equals 0, I will make 1,000 shoes. And we got to make sure all their IDs are different. So we'll just make the ID is equal to I. Now, as it goes through the loop, the I will change, so the ID will change. So we run this. And we get 1,000 shoes made. What's this? 100,000. Let's run this. Let's just show you there's really no limit. It takes a little bit longer because it's looping 100,000 times. Actually, yep, and there we go. We got 100,000 shoes made. And really, we didn't have to do anything with like messing with the numbers up here in the array. We didn't have to do like a check to see if there were too many shoes already in it. So let's make this down to something more manageable. Let's make it back down to 10 shoes. Okay. So that's how you could do this example with an array list. But I'm going to do you one better. So with these shoes, as with your assignment, your book has an ID, right? And an ID is what that book is, right? Just like with our shoes has an ID and it uniquely identifies that shoe, right? Just as in your assignment, you have an ID that uniquely identifies that book. Okay. Well, what if we do this? And if I was making this program for like a shoe company or something in real life, this is what I would use. I would use what we call a map. Oops. Specifically a hash map. And I'll explain to you how it works here in a second. Hash map. And here I'll have an integer. So it is a hash map. As you see here in brackets, when you have these things like array lists and maps and things like that, inside the brackets, you're telling the compiler what are the types that I want to work with. So whenever I had let me go back to my array list. When I had the array list, I'm telling it the type is shoe. Inside this array list, I'm going to store some shoes, right? This could have like doubles in there if I wanted doubles. I misspelled it, but you see the point. That means I want to store doubles in the array list. But because I have shoe, that's telling the compiler I'm going to store shoes in this array list. As you can see here, whenever we did add, we added a shoe to it, right? So when we have a hash map, new hash map, we actually have to give it two types. The first one I'm going to use is an integer, and the second one is going to be a shoe. So what does this mean? What a map does, it uses this input to look up this output. Meaning in this hash map, if I give the hash map an integer, it's going to give me back the shoe of that integer. So think of this as the ID. So I'm going to store the IDs and how they relate to each shoe. All right, I actually got to wrap this up pretty quick, so we'll go through this a little bit faster. So anyway, this is a hash map. It's going to change up how we add it a little bit, meaning when we do shoes.add, excuse me, it's no longer add anymore. It's now put, because it's a map, and we have to give it the ID that we want to put, the shoes ID, and we'll put the shoe there. So that means inside this map, whenever there is this ID, I want it to be associated with this shoe. So how does this help us? We'll change this value, size. Actually, it's going to be a little bit different. I'm not going to worry about the print shoes right now. I'll leave that exercise to you. It's only because I'm limited on time now. So what this can do, it can greatly simplify the does ID exist. And how is that? Now all I have to do, I can just return shoes dot contains key this ID. Greatly simplifies it and actually significantly speeds up this program. So this is saying in this shoes map, does it have this key? As I said, this is the key and this is the value. This is what I want to look up and this is what the value is actually there. So I'm saying, does it already have this ID as a key? True or false? So let's run this last example and then we'll be done. 1, 2, 3. What was it? Brand, size 12, whatever. Let's try to do 3 shoes. 2, 3, 4. And then we'll go back to 1, 2, 3 to show you how it catches it. A6, New Balance. So whenever we add a shoe, let's print out that add the shoe. Added shoe. All right, let's run it, look at the output, and then we'll look at the code for it. All right, so there we go. We added this shoe, so we're making this shoe 1, 2, 3 Nike. So we added that shoe. Now we try to add the next shoe with a different ID, and it works just fine. But when we try to add the third shoe with a repeat ID, it tells us, sorry, this ID already exists. Actually, I will show you that print real fast. Print private static void print all shoes, because it is a little bit different from your standard loop. So you need to make a loop equals 0, I less than. So we need to iterate over all the actual values of the shoes. So we have shoes, so we have keys, or we have values. Values is what we want because values is the shoes itself. Actually, let me show you the other loop. For integer key and the shoes dot key set. So this will do a loop. It'll loop over all of the keys, meaning this key, this key, this key. So let's get the shoe at that key. Shoes dot get at that key. And then we'll just print the shoe. Print ln shoe. There we go. So here at the end, let's go back and do the print all shoes. Let's run it, and you'll see we get what we expect. And then we'll wrap this up. There we go. So we added the first shoe, we added the second shoe, we tried to add the third shoe, but it had a duplicate ID, and then we go print all the shoes, and it does print all the shoes for us. So this is another thing, like I said, you can use a raw array, you can use the array list, or you can use a hash map. I will not count off whichever one that you want to use. I'd actually encourage you to use the array list. It's probably the simplest to use out of those 3 examples. All right, and that's it for this week. So we got a few more minutes. If you have any questions, go ahead and ask them now, and I'll stand by. For Java, does the hash map keep order, or is it unordered like earlier Python versions? It is unordered. So if you look at what we did here, where's my mouse? So we added this shoe 1, 2, 3. We added this shoe 2, 3, 4. You had one that didn't get added. But when we printed out all the shoes, it's in a different order than what we inserted them as, right? And that is correct. A hash map, or any map in general, does not maintain the order it was inserted in. So if you do need to maintain the order, then you need to use an array list or a linked list, or there's several other varieties. But it boils down to a list or a map. If the order is important to you, use a list. If the order is not important, then use a map. We use a map if you're doing things like an ID for individual items. Let me say it that way. Okay. And for your assignment, the order of the books doesn't matter. You just need to be able to add, remove, find, and display them. The order that they're stored as doesn't really matter. I mean, like with our shoe example, whenever all the shoes are out there on display and everything, doesn't matter what order the shoes are lined up as. Not really. You just need to know that the shoes are there. Yep. Like I said, follow. I'm a big stickler about following the specifications of the assignment. If you want to do things above and beyond, then I'm not. Then that's fine. I won't mark points off if you do extra stuff, but if your extra stuff does not work, or especially if your extra stuff causes the program to crash, then you will lose points. So I would stick to exactly what the assignment is asking you to do. Will you be antagonistic when grading? Like, will you put in a string instead of int for the ID? I mean, for this level of class, you do not need to do error checking on the input. Certainly in real world code, you have to extensively check the user input because the user is terrible, right? The user will always do something wrong. But for this class, I do not expect you to do error checking like on user input or something like that. So no, you don't need to check. If you're storing the IDs as an integer, you don't need to check if I put in a string, and vice versa. If the ID is a string, you don't need to check if I typed in an integer or whatever the case is. So no, you don't need to do that level of error checking. Yeah, that's fine. I mean, that's certainly what you have to do professionally. But I mean, the syllabus for this course is not teaching you how to error check, I guess. I mean, should you? Yes, you should do error checking. Because if you go out to a company and you write code for a company and you don't do error checking, you'll probably find yourself unemployed rather quickly. So it is definitely good practice, but it is not. I mean, it goes back to what I said about following the directions in the assignment. The directions say nothing about doing error checking. So I do not expect you to do error checking in your program. If you do, that's great. But if you don't do error checking, I'm not going to dock you points because the assignment doesn't tell you to do error checking. All right. We've got about 2 minutes left. Is there any last minute question you may have before we shut it down? For the Army, I don't know if you're in the Army or in one of the other services. I'm actually 26 Alpha. I'm a trained actually network engineer, but I have been in cyber for the past 5 years. My previous job, I did reverse engineering and malware analysis. And my current job, I work with the Army Red Team. And so we do penetration testing and we basically hack Army networks to find vulnerabilities, and then we go fix those vulnerabilities for them. So that's what I do now. So officially, I don't work on any official Army software, but I do develop software internally that my Red Team uses. we are going to have to go because I scheduled this for an hour and a half, so it's probably going to shut down automatically here on me in a second. So if you have any additional questions, please email me directly and I'll try to get back to you as quickly as I can. All right. And as I said, I will get this posted up, I think on YouTube here in the next hour or so, and I'll get the link sent out. So everybody have a good night or good evening, good Sunday.